By the end of this lesson, one pipe character becomes real power, chains that stream, run in parallel, and even mix in your own Python. Here's the plan. The LCEL pipe, prompt to model to parser. The three verbs every piece shares: invoke, stream, and batch. Then the power tools, RunnableParallel to run chains together, pass-through to keep your context, and RunnableLambda to drop in your own function. And finally, going async. And one rule for this whole series: don't just watch. It's hands-on. So open your editor and code along with me. Typing it, breaking it, and fixing it yourself is the only path to mastery. Let's set it up. Here's the fastest way to start a LangChain project, with UV. One command, UV init, scaffolds everything: a pipe-reject file, a pinned Python version, a virtual environment, and a starter main.py. Add your libraries with UV add, LangChain, LangChain OpenAI, and python.env. And watch, if you fat finger a name, UV stops you cold, not found. Fix the typo, and it resolves and locks the whole dependency tree in seconds. To run it, you don't even activate anything. UV run executes inside the project's environment. And there it is, hello from LangChain Lesson 3. A clean, reproducible LangChain project, ready to build on. Welcome. In this lesson, we're going deep on LCEL, the LangChain Expression Language, the piping syntax that everything in LangChain is built on. By the end, you'll fluently chain prompts and models, stream and batch them, run pipelines in parallel, and even plug in your own Python. But first, one word on configuration. My secrets live in a .env file, which I never commit. Next to it, I keep a .env.example. It shows the shape of what you need, an OpenAI API key and a base URL, but with no real values. That's the file you share, so teammates know what to fill in. All right, let's write some code. We start with the imports, and each one earns its place. Load_dotenv from the dotenv package reads that .env file, so our key and endpoint become available to the program. Chat OpenAI from LangChain OpenAI is our model client, the object that actually talks to the LLM. Chat prompt template from LangChain core prompts builds our prompt, the same pattern we used in lesson 2. And str output parser from LangChain core output parsers takes the model's raw response and gives us back clean, plain text. Inside main, we first call load_dotenv so the environment is ready. Then we create the model client, Chat OpenAI, with the model set to GPT-4o mini. And notice one argument, temperature, set to 0. Temperature controls how random the model is. Large language models are non-deterministic, so the same prompt can give different answers each time. Temperature 0 pins it down, the most focused, repeatable output. Crank it toward 1 or 2 and you get more variety and creativity, but less predictability. For a tutorial, where I want the same clean answer every run, 0 is exactly right. Now the prompt. Chat prompt template from template and the text. Explain a topic in one sentence. That word topic, in curly braces, is a variable. We'll fill it in when we run. And here is the single most important line in all of LangChain, the chain. Prompt, pipe, model, pipe, string output parser. Read it left to right. The prompt's output flows into the model, and the model's output flows into the parser. That pipe character is LCEL. It's how you compose steps into a pipeline. Before we run it, let's answer the question that unlocks everything. What actually is that chain? It's a runnable. In LangChain, a runnable is any component that speaks the same three verbs. Invoke, run it once and get the answer. Stream, get the answer piece by piece as it's generated. And batch, run many inputs at once. Here's the beautiful part. The prompt is a runnable. The model is a runnable. The parser is a runnable. Because they all share that identical interface, the pipe operator can snap any of them together, and the chain they form is, itself, a runnable, which you can again invoke, stream, or batch. Everything is a runnable, so everything composes. Hold on to that idea. It's the whole lesson. Let's run it. We call chain.invoke and pass our variable, a topic. First, I try just LCEL and watch. The model guesses completely wrong, some energy term, because those 4 letters are ambiguous on their own. So I make the topic specific, LCEL in LangChain. I run it again, and now the answer is more on target, 1 sentence about LangChain. Small lesson, your input matters as much as your code. Invoke gives us the whole answer in one shot. But that's not how models actually work. They generate 1 token at a time, each token predicted from everything before it. If we want to watch that happen live, we don't rewrite the chain, we just call a different verb, stream. We loop over the chunks as they arrive and print each one, with flush set to true so it shows up instantly instead of waiting in a buffer. Run it, and the answer types itself out, token by token, in real time. Same chain, 1 word changed. What if you have more than 1 input? You could loop and call invoke over and over, but there's a better verb, batch. I put several topics in a list, LCEL, AI agents, and RAG, and call chain.batch. LangChain runs them concurrently, not one after another, and hands back all the answers together. This is what you reach for with bulk summaries, grading, or evaluations, where you have many inputs and want speed. Now a genuinely new pattern, RunnableParallel. Everything so far was 1 pipeline, but real applications often have several different chains that aren't related to each other, and you'd like them to run at the same time on the same input. Because chains are runnables, you can. I build 2 small pipelines, a summary pipeline, prompt, model, parser, that summarizes a topic in 1 line, and a quiz pipeline that writes 2 quiz questions. Then I wrap them in RunnableParallel, giving each a key, summary, and questions. When I invoke this, both pipelines fire off in parallel, and I get back a single dictionary with both results. I run it, and it blows up. Now, don't fear a red traceback. Read it from the bottom. It says, type error, base model takes 1 positional argument, but 2 were given. What happened? Look closely at my pipelines. I wrote str output parser without the parentheses. That passed the class itself into the pipe, instead of an instance of it. So LangChain tried to build the object using my data as an argument. It's one of the most common beginner slips in LangChain. The fix is tiny. Add the parentheses, and now it's a real parser object, a proper runnable. Run it again, and this time it works cleanly. We get back the 1-line summary of our topic and the 2 quiz questions, both generated together, in parallel, from that single input. Next, RunnablePassthrough, and it's a small idea with a big payoff. RunnableParallel gave us the summary and the questions, but it threw away our original input, the topic. Often you need to keep that context flowing downstream. Pass-through.assign does exactly this. The 2 chains still run in parallel, but it also carries the original input forward and merges it into the result. I build enriched with pass-through.assign, invoke it, and now the return dictionary has 3 things: the summary, the questions, and the original topic, all preserved together. Now RunnableLambda, my favorite. Every chain so far has ended at the parser, giving us text. But in the real world, you usually want to do something with that text. RunnableLambda lets you drop any plain Python function directly into the pipeline. To show it, I write a tiny function called shout that uppercases whatever it's given. Then I build a chain, prompt, model, parser, and my shout function, joined with RunnableLambda. I run it, and the model's answer comes back in all capital letters. My own code ran inside the LangChain pipeline. That's your escape hatch for anything: cleaning, reformatting, calling another API. Now let's put the whole lesson into 1 pipeline. I write a function, format card, that takes the full dictionary and lays it out as a neat card, the topic as a heading, a TLDR summary, and a quiz. Then the app, pass-through.assign, runs the summary and quiz chains in parallel and keeps the topic, and that whole thing is piped into RunnableLambda with format card. 1 invoke, and out comes a finished, formatted card. Look at everything working together: parallel execution, preserved context, and my own function in a single LCL pipeline. One last piece, async. In a real application, you can't freeze your whole program while you wait on the model. So every verb we've learned has an asynchronous twin, ainvoke, astream, and abatch. And watch, I make a deliberate mistake here. I use ainvoke where I actually need astream, and Python tells me exactly what's wrong. Async for requires an object with aiter, but it got a coroutine. The fix is to use astream, the async version of streaming. I run it, and we get that same live, streaming answer. Only now it's non-blocking, ready for production. And that's LCL, end-to-end. The one idea to remember, everything is a runnable, so invoke, stream, and batch work on every piece. RunnableParallel runs independent chains together. Pass-through carries your context forward. And RunnableLambda drops your own code into the pipe. This composability, snapping small runnables into bigger ones, is the exact foundation we'll use to build real agents in the lessons ahead. You don't need to memorize any of this. Let me show you where it all lives, the official LangChain docs. This is the overview page. It frames the big idea. A LangChain app is a model plus a harness around it, and it walks you through spinning up your first agent. Now the streaming page. This is where the stream and batch methods we just used are documented. It goes deep, but the basics are simple. You can stream the agent's progress step by step, stream the model's tokens as they're generated, and pick a stream mode to control exactly what you get back. But the page to bookmark is models. It documents the model client end to end. And look at the three key methods, the exact runnable verbs we used in the code. Invoke, to run once. Stream, to get output as it's generated. And batch, to run many inputs at once. Scroll on, and it documents everything else in detail. How to structure your messages, set parameters like temperature, and handle tool calling and structured output. So whenever you're stuck, come here first. The docs are the source of truth, and now you know exactly where to look. Next, let's get this code onto GitHub. And everything we built is on GitHub, free and public. The whole series lives in one repo, Techfluencer, Agentic AI LangChain. And you can see the commit I just pushed right here, add lesson 3. Open the lesson 03 folder, and there's today's main.py. Every LCL pattern we built is in this one file, invoke, stream, and batch, RunnableParallel, pass-through, and lambda, and the async version, all ready for you to copy and run. The README walks you through cloning it and adding your own key. The link is in the description, so grab the code and follow along. Let's test what you learned. 10 quick questions on LCEL. I'll read each one and then pause. You pick your answer, and then I'll reveal it and explain. Ready? Let's go. Question 1. What interface do all LCEL components share? Your options. A. Callable. B. Runnable. C. Chain. D. Pipeline. Pause now and pick your answer. The answer is B. Runnable. Every LCEL piece, the prompt, the model, the parser, is a runnable, so they all support invoke, stream, and batch. Question 2. Which operator composes LCEL steps into a chain? Your options. A. Ampersand. B. Plus. C. Pipe, the pipe. D. Double greater than. Pause now and pick your answer. The answer is C. Pipe, the pipe. The pipe sends each step's output into the next, prompt, then model, then parser. Question 3. Which method streams the output token by token? Your options. A. Invoke. B. Batch. C. Stream. D. Fetch. Pause now and pick your answer. The answer is C. Stream. Stream yields chunks as they're generated. Invoke returns the whole answer at once. Question 4. Which method runs many inputs at once, concurrently? Your options. A. Stream. B. Batch. C. Map. D. Gather. Pause now and pick your answer. The answer is B. Batch. Batch takes a list of inputs and runs them together, ideal for bulk summaries, grading, or evals. Question 5. In this chain, what does string output parser do? Your options: A. Sends the prompt. B. Chooses the model. C. Returns the raw model object. D. Extracts the reply as plain text. Pause now and pick your answer. The answer is D. Extracts the reply as plain text. It strips the model's metadata and hands back just the clean text string. Question 6. Which Runnable runs two independent chains at the same time? Your options: A. RunnableParallel. B. Runnable sequence. C. RunnableLambda. D. RunnablePassthrough. Pause now and pick your answer. The answer is A. RunnableParallel. RunnableParallel runs branches concurrently and returns a dict of their results. Question 7. Which carries the original input forward and adds new keys? Your options: A. RunnableLambda. B. RunnablePassthrough.assign. C. RunnableParallel. D. String output parser. Pause now and pick your answer. The answer is B. RunnablePassthrough.assign. Assign keeps your original input, like the topic, and merges in new keys, so downstream never loses context. Question 8. How do you drop your own Python function into a chain? Your options: A. Put a def in the pipe. B. RunnableLambda. C. Model.bind parentheses. D. Chain.map parentheses. Pause now and pick your answer. The answer is B. RunnableLambda. RunnableLambda wraps any plain function so it becomes a runnable in the pipe. Question 9. What does this line raise? String output parser with no parentheses. Your options: A. Syntax error. B. Key error. C. Type error. D. Nothing, it works. Pause now and pick your answer. The answer is C. Type error. You pass the class, not an instance, so you get a type error. Add the parentheses to fix it. Question 10. What is the async version of stream? Your options: A. Stream_async. B. Astream. C. Async_stream. D. Await stream. Pause now and pick your answer. The answer is B. Astream. Every method has an async twin, an invoke, a stream, and a batch for non-blocking production code. That's all 10. However you did, you now understand LCEL end to end. Rewatch any section you're unsure of, and I'll see you in the next lesson. Before you go, here's the real secret. Nobody masters this in a day. LCEL clicks when your fingers know it. So retype these chains until the pipe feels natural and build one small thing of your own. Everything we wrote is waiting for you on GitHub, and the link is right there in the description. Clone it, break it, rebuild it. That is how it actually sticks. And if this helped you, subscribe and tap the bell so the next lesson finds you the moment it drops. It genuinely keeps this series going. Thanks for building with me, and I'll see you in the next one.